compute. So we are clicking here. We are going to R Markdown. Yes, giving it a name. Kostiaev, problem set 8 in class. And you give your name. We click OK. And we do it one more time. Yeah, it's annoying. Oops. Okay, let's see. Oops. So with R Markdown, we need some like space to do stuff. So what we are doing, we just copy pasting this below like a few times to create a space for different chunks of code. Don't forget to like save stuff just in case your laptop crashes. Okay, let's see what we have. Problem set 8. First, we need to import data. COVID data 9/16/21. File, import data, file, import data set, readder, browse, documents, so let's see, we need, oh, that's weird, I don't have it. Okay, so I forgot to do it, so let's place it where it's supposed to be. Again, if you're in Safari, it might open as a window, so you need Google Chrome for that. Yeah, let's rename it. You see, since I already saved it in downloads, it has this one, so let's get rid of it. Oh, shit. Let's find it in this case. Okay, we need 21. Okay, now we should have it. File, import data, readder, browse, COVID data, open. Let's see what we have here. Okay. Yeah, it doesn't allow me to scroll at this moment. So if something will not work, I will give them numeric values later. Yeah, here it is. Always annotate your code. It's a letter for yourself from the past. And we need to get rid of this stuff. Running the script to stats. And let's renaming. We click this triangle. Okay, let's see what we have here. Okay, run linear regression where confirmed deaths is dependent variable. Government response index, total population density are independent variables. So run it, we need to make sure they are all interval ratio. So let's see. Confirm cases, obviously. Guys, could you please? So confirm cases, confirm deaths, obviously numeric. Government response index, obviously numeric. Total population, obviously numeric. Population density as well numeric. So I guess we should be fine, right? Okay. Running linear regression. Oh, I can do it here as well. Okay, let's see. Again, I can give it whatever name I like. So what we need, and again, R is case sensitive, right? So let's check. I can just copy paste it, right? And then we have this operator. Let's see if I can find it. It should be somewhere. Here it is. After this operator, we have our independent variables. So what we have, government response index. Let's see. Here it is, government response index. Again, we just copy paste it so we don't mess up cases, uppercase, lowercase. If I remember right, we have a bunch of pluses. Okay, what else? Government response index, total population. Okay, total pop. Okay, what's next? Population density. Pop density. And then we type name of the data set, if I remember right. Ah, shit. So this is our model, I think. Let's see if I remember the code. Oh, I do remember. Okay. So how we can interpret this adjusted R-squared? Yep. Nope, 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 nope. So yeah, so 9.1% of change in confirmed deaths. Let's see, what's our dependent variable? Confirmed deaths is explained by independent variables we have in the model. So this is how you interpret R-squared. So if you didn't correctly do a resubmission and get at least 3 points. Okay, let's see. What can we say about our coefficients? Are they statistically significant or not? Yep. Yep, confidence interval. And let's see how we interpret government response index coefficient. What can we say about it? Anyone? Again, general interpretation. Coefficients in linear regressions are usually percentages. So one unit change in independent variable, in this case, one unit change in government response index leads to 98% change in death. But since like we are already pretty, like we do know, we can provide more specific interpretations. Since we have confirmed deaths as dependent variable, we can say that one unit change in government response index leads to 98% increase in confirmed deaths. Again, we don't know like what the hell is government response index. When I looked at the data, I wasn't able to find the code book, so we don't know exactly like what the hell is this index, but this is like general interpretation. And coefficient for total population, since it's a bunch of zeros, we can't really interpret it. Like we have so many zeros that there are like no percentages, no meaningful percentages. Actually, no, sorry, I am wrong. You see adjusted R-square. If we have a second number after zero, it's 9%, right? So over here it should be, what is it? So if we had two zeros here, it would be 65%. But we have like, what is it? So it's 9,865%, I guess. Yeah. But again, our regression is bullshit. We just picked like a random variables from a data set. The reason we are doing it is that dependent variable is interval ratio. When I was trying to look for data sets to practice linear regression, I wasn't able to find many data sets with where we can use dependent variable, which is interval ratio. So this particular results I would say in real life, we probably won't be able to publish anything like this. You see? Okay, so this is, again, general interpretation of coefficients in linear regression. One unit change in independent variable leads to a new, put this coefficient, this percentage change in dependent variable. This is like general interpretation for, yep.
So is it the estimate or the decimal points down there?
Yeah, so for instance, let's look at this population density. The sign of the coefficient makes like no sense. Do you understand? Can anybody explain why sign in population density coefficient makes like 0 sense?
I guess in that situation, if you were to answer, say, 1 unit change in population density leads to a negative 3%.
Which we, from like COVID experience, we all know it's bullshit, right? The higher the density, the higher the number of deaths. So linear regression is not some kind of miracle. Sometimes you build a model which is absolute bullshit, which gives you results which make no sense. And it's your responsibility as a scholar to build a model which actually makes sense. If you build a model where coefficients makes no sense, it means, well, you're a bad researcher. Again, linear regression is not, there is no magic here. It's up to you to decide what kind of variables you include in your model. So in this particular case, it would mean 1 unit change in population density leads to 23% decrease in deaths, which is like bullshit, right? Okay, so what's the next step would be? We interpreted adjusted R square. We interpreted statistically significant coefficients. Let's check for heteroscedasticity. I don't remember how to do it, so let's see. Okay, linear regression. By the way, it's weird. I was able to do this code without setting up working directory in every chunk. Let's see if it works. Sometimes it gives you weird errors, and this is why I'm doing this. R Markdown has more bugs than R script. That is true. So we just copy paste this stuff. But we over here, we need to, oops. Oh yeah, I screwed up. What's going on? Okay, yeah, let's do just the code. Yeah, and I need this thing. And let's get rid of this stuff because it's weird. Okay, let's just do the code. And again, what we are doing here, we just replace the name of the model. And I decided to name this model Cove model. So what we do, we just replace P1 with Cove model. Let's see. Okay, how we can interpret this stuff? What can we say about this plot? Yep.
Might be.
Yep. And it means that we probably have a muted variable bias. This model needs some additional independent variables. If we had all the variables we needed, distribution of errors will be random. Okay, what's next? We interpreted the plot. Yeah, let's write it down. So let's do this. What's good about our markdown? You can just say since. I think we can do this. Since distribution of residuals is not random, we have here heteroscedasticity in this model, which indicates muted variables bias. Okay, what's next? Interpret the plot, run our markdown, produce HTML, save HTML as PDF. Okay, let's see. Yeah. Knitr HTML. Let's see if it works. Oh yeah, I love our markdown. Yeah, this is maybe this is why I really need to set up working directory every single time. Let's see if it works. Yeah, voila. And now this is what I want you to submit. File, print. Print. It's supposed to give me option to create PDF.
You have to save it first, and then you click on it, and do Command P.
Okay, let's try. So file, save. Okay, save. Uh-huh. Oh, okay. Let's so file, print. Yeah, PDF. Save as PDF. And I guess print. Oh, why it disappeared? File, print. Let's try open and preview. Yeah, finally, yeah. But it doesn't have.
That's why I had to save it as. You have to open it like on the browser, so save it. And then it gives it to you.
Okay, let's try one more time. It says RMD, doesn't say HTML for some reason. This is weird. Yeah, this is why I hate R Markdown. But okay, print. Let's do this one. I need to open it in Chrome. Here?
Next to the font.
Open in browser. Okay. Yeah, I think now I should be able to do it. Yeah, finally, yeah. Okay, let's see. Yeah, finally. Is anybody behind? Does anybody need time to do it? Raise your hand.
Very similar PDF, but doesn't look like this.
Like, does it has the plot? So guys, could you please resubmit? Maya knows it, and Vincent, and I need to.
Yes, I don't. Log on there, think about
Let me stop recording. It can be done. I just did it with some help. It's not like impossible task.